So I want to get people to get me their questions early. If you have questions from the homework in the maths that you did this weekend, then you need to get them in now rather than throughout the session. Um, yeah, that's it. I've had a question already. I can answer a couple. Um, yes, so booklet 3 and 3, excellent, right, good, 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 right, fine. Let me start in order. I'm going to go to booklet 3, question 1. Aha, I did this a little while ago. This is a difficult question. There are some harder questions in this than others. There are some easy questions in here. There are some harder questions depending on how much of surds you got through. Oh, look at that, our website. Okay, I'm going to do it relatively quickly. Difficult question, this. First of all, in this question, you need to work on the top and the bottom of the fraction separately. On the bottom of the fraction, you have these two multiplied together, which just make the square root of 6. That's what happens with surds. You multiply them and they just multiply as normal. Then what you do is look at the top. On the top, you have this square root of 150. One of the big things about these surds is that you can simplify them by finding two numbers that multiply to give that number inside. In this case, 25 and 6 multiply to give 150. And the important part of this is making sure that this number is a square number, so it becomes a whole number when you square root it. And then you attach the 6 onto it. So on the top now, I have changed the square root of 150 to 5 square root 6, and I've got this minus square root 6. 5 of these minus 1 of these is 4 of these. So now we've got to there. And on the, and then because we have a square root of 6 on the top and the bottom, they can cancel out, and the answer is 4. That is an integer. I'm going to do these literally in order they've been asked, okay? So, 17, 21, 22, and 23 in booklet 1. Let's have a look. 17. Sort these cards into 3 pairs so that each pair has the same total. Okay. Oh, God. Got it. -7 add 2 makes -5. -5 add nothing makes -5. -3 minus 2 makes -5. We have sorted the cards into 3 pairs, so each pair has the same total. Done. 21, 22, and 23. Circle the value of 10 to the power 6. That's just 10. Oh, God. Followed by 6 zeros. Isn't it? No, it's not. It's 1 followed by 6 zeros. Yes, which is a million. That's the answer. 22. Circle the value of 2 with a little 4 on it. You should really know this, but that means 2 times 2 times 2 times 2, which I'll let you figure out. This means 5 times 5 times 5, which I will let you figure out. Circle the value of this, the square root of 196. Oh, God. Is it 14? It must be 14. Um, yeah, because you can check it by doing 14 times 14, and it should be 196. 23, work out the value of this. This is 3 times 3 times 3. You're adding it to 4 times 4. 3 times 3 times 3 is 27. 4 times 4 is 16. 27 out 16. I'll let you work it out. This one, a bit harder. So 5 to the power of 3 is 5 times 5 times 5, and we're minusing 10 squared, which is 10 times 10. That is 125, and that is 100. 125 take away 100 is 25. 25 can be written as 5 with a little 2 on it, and that's what it means by as a power of 5. The answer you can write like that. And that is all of those questions. Booklet 3, question 3. Oh. This one. This again requires simplifying of these surds. The square root of 12 can be written as the square root of 4 times the square root of 3. That square root of 4 can become 2. So we just stick the root 3 onto it. This 75 can be written as the square root of 25 times the square root of 3. The square root of 25 is 5, and then you stick the root 3 onto it. So we've ended up with this as being that, and this as being this, and we're adding them together. When you are adding these two together, you can just add the 2 and the 5 to make 7. Lots of root 3. 4 and 6. Work out the value of this. Right. When you have a minus power, what that tells you to do, and this is very important, if you've got to remember one thing from today, remember this. When you have a minus power, you flip over whatever you've got. So it becomes 7/5. But that 2 is still there. And that 2 tells you to square the top and the bottom. The top becomes 49, the bottom becomes 25. And then that is an improper fraction, which you should know from Key Stage 2, how to turn into a mixed number. 1/25 goes into 49. The remainder is 24, and the 25 stays on the bottom. It's 1 and 24 over 25. 6. Quite a difficult question, this, but I will tell you. What you have to do here is you have to expand these brackets. The way you expand the brackets is by doing that times that, which is 15. That times that, which is minus 5 root 3. This times this, which is minus 3 square root 3. And this times this, the minus and the minus makes a plus, and you get the square root of 9. When you have two surds, then you can change the number in the middle by just timesing them. And that becomes 3, because the square root of 9 is 3. And then we simplify what we can. 15 add 3 is 18. Minus 5 minus 3 is minus 8, lots of root 3. And then because all of this is being divided by 2, you can divide the 18 by 2, and you can divide the 8 by 2. The root 3 stays where it is, and that becomes the answer. 8B, booklet 2. I'm just doing this in order that they're being asked. This is being recorded as we speak onto the YouTube. 8B, booklet 2. Work out this, right? When you are squaring something, it means you're multiplying it by itself. So that is being timesed by itself. Very similar to what we just did. Right. The way we do this is, what I would do initially is expand these out. The way you expand a pair of brackets like this is you make sure that everything in one bracket is timesed by everything in the other bracket. Right. The square root of 6 times the square root of 6 is the square root of 36. The square root of 6 times the square root of 12 is the square root of 72. Then we'll move on to this 12. Square root of 12 times the square root of 6 is another square root 72. And the square root of 12 times the square root of 12 is the square root of 144. Okay, and then you start to simplify things. This is 6, and this is 12. We should know the square root of these numbers if we know our times tables. The 72 is more complicated, right? The 72, you have to simplify. There are two numbers that times to give 72, one of which is 36, which is helpful because that becomes 6. So the square root of 72 can be written as 6 root 2. And so can the other one. 6 add 12 makes 18. And these two 6s make 12 lots of root 2. And that is the answer. Maybe booklet 3, question 3, I think I've done that. Yeah, done that. Booklet 3, question 6, done that as well. 4, 5, and 6. 4 I've done. 5, 6 I've done. 5, circle the values equivalent to this. Again, all of this is about, and I get that you might not have done too much of this in your lesson, but the crucial thing about this topic, which especially if you're in year 8, is a little bit early, but for you guys in year 9, you'll need to know this soon. It's about simplifying these things. The way you simplify them is you find two numbers that multiply to give that number, but you want one of those numbers to be a square number. So a number that when you square root it, it becomes a whole number. So that is 5, and then you stick the root 2 onto it. So that's 5 root 2. And do the same with the 32. I know that 16 and 2 make 32, and 16 is a square number 4, or square roots to 4. And then these two added together makes 9 root 2. Done. And then this one, a little bit harder, but we've got 4 root 75 divided by 2 root 3. The easiest way to do this is 4 divided by 2, which is 2, and then 75 divided by 3 is 25, well, it's the square root 25. The square root of 25 is 5, so it's become 2 times 5, which is 10. I've done that, done that. 16, booklet 1. Did I do that? No, I've done that. 16. Here is a list of numbers. Let's write down two numbers that add up to 5. Ooh, okay. 6 and -1. That works. Two numbers that have a difference of 13. -9 and 4 have a difference of 13. Like if you had a number line and -9 was here and 4 was here, then you would jump 13 steps before you got to it. So that's a difference of 13. Two numbers that multiply to give -15. That will be -5 and 3. Three different numbers to make the following calculation. Like 20 divided by something equals something divided by something. Um, don't know. 20 divided by 4 is 5, and -5 divided by -1 is also 5. That's probably what I would go with. If someone just says question 5, oh, booklet 3, question 5, booklet 3. I think I just did that, didn't I? I did that. Yep, 5, booklet 3. Is this a plus? I don't know what that means. That must be a question I did a while ago. Um, question 10. On here. This negative power means that you flip over this 3. If you flip over a 3, it becomes a third. That 2 is still there. What that 2 does is it squares the 1 to 1 and squares the 3 to 9, 1 over 9. This question, work out the value of this. This is a difficult question, this one. Yeah, the printing on this might have looked like a divide, but I think I did what I thought it was. Right, anything to the power 0 is 1. Okay, so the hard bit about this question is figuring out what this is. Let's write it down over here to explain what to do. Firstly, the minus power flips over your 8. And now we've still got 2/3, right? 2/3 is quite complicated because what happens here? Firstly, the 1 to the power 2/3 doesn't do anything, so there's still a 1 on the top. It's the bottom that's tricky. 8 to the power 2/3. That means that you cube root the 8. That's what the 3 does at the bottom. And then the 2 goes outside. The cubed root of 8 means a number that when you times it by itself and then itself again, you get 8. And that number is 2. So the cubed root of 8 is 2. There's a little squared outside it, which makes 4. So the bottom of this becomes 4. So 8 to the power minus 2/3 is a quarter, which means the question is 1 plus a quarter, which is 1 1/4. Booklet 119B. Let me have a look at that. Choose a card, so the answer is as small as possible. As small as possible, you want to take away as big as possible. You want to take away 8.9. The problem with choosing this 8.9 is if you put another minus there, these two become an add, so the answer gets bigger. We want to be as small as possible, so we're going to put a plus 8.9 there. You want to take away as much as possible. That makes the whole thing smaller. 5, booklet 3, I think I've done. Yep, 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 yep. Booklet 3, question 10, did I do that? Yep, done that. And 11, 11. Work out the value of 27 to the power 2/3. Given what I just did, this should be a bit easier. The 3 on the bottom tells you to cube root the 27. And then the 2 on the top tells you to square the answer. The cubed root of 27 means a number that when you times it by itself and then by itself again, you get 27. That number is 3. Because 3 times 3 times 3 is 27. That goes in there. The 2 is outside it. 3 squared means 3 times 3. The answer is 9. 13C. Right, this is tricky because I can't tell what that is. I think that's a plus. Okay, right. This says the square root of 3 to the power 0, which is 1, times 3 to the power 1 plus 3 to the power 2. 3 to the power 1 is 3. 3 to the power 2 is 9. Okay, so that's become 1 times 12, which is just 12. The square root of 12 can be simplified to the square root of 4 times the square root of 3. And this becomes a whole number 2 when you stick the root 3 onto it. The answer is 2 root 3. 10, 11 done, 10, 11 done. Question 9. Oh, oh no. Question 9. Right, I'm going to only help you part way into this. I'm going to tell you that the square root of 75 is the square root of 25 times the square root of 7. Yes. Okay, that should be enough for you to finish the question off, given what I've been talking about. 10, 11, 10, 11. Okay. 17, booklet 1. I think I've done that. Feel like I've done it. Yep, done that. Okay, so that was here. It's in the recording if you need it. Um, 11 on booklet 3, I think I have done. Yep, done. 17, done that, done that. Did I do that just now? Yes, I did. 17. Yep, there it was. Um, just for future reference, guys, you can ask the question once and I will get to it. Promise you. Booklet 3, question 14. I'm not answering that. Sorry, because you should be able to do that really easily. That is a divide. So with this one, the rules of indices tell you that when you are dividing two numbers with powers, when the big number is the same, you can minus the powers. So 12 take away 3 is 9. So this bit becomes 5 to the power 9, and then you're timesing it by this bit. When you are multiplying numbers together, when the big numbers are the same, when there's powers, you can add the powers together. 9 add 2 is 11. Um, how do we do part B? Again, I don't know what you mean by that. You have to specify as I'm going through these. Question 12, booklet 3, just done. Of 9. 9B, booklet 2. Oh yeah, that, to be fair, you probably won't have been taught it because this kind of snuck in wrongly into this booklet. But I'll tell you just for now. You will learn this if you haven't learned it yet. So the idea of this is you multiply this fraction by whatever you have on the bottom but like twice. So you times the top by the thing on the bottom, and you times the bottom by the thing on the bottom. If you do that, you get 24 root 3 on the top, and the square root of 3 times the square root of 3 is the square root of 9, which is 3. And then you get 24 over 3 here, which is 8. And 8 root 3 becomes the answer. Question 12, booklet 3, I think I've done. Yeah. 15 and 17. Yeah, 15 is quite hard. 17 is not easy either. Right, let me do 17 first. So, question 17. Again, the whole point of this is just like, given what I have been doing throughout today, it is about finding two numbers that when you simplify them, let me just see where we're up to now. So we are on 12B booklet 2. Right. The last person asked a question, 12B booklet 2. That is the last question I will answer, just so you know. So I'm not going to go anywhere beyond 12B booklet 2 at 7:35 p.m. Right. Question 17. There are some mistakes in some of these, occasionally a couple of these. So I'll explain what rationalize means. You might not have got to this in the lesson, because it's just sort of it's kind of wrongly stuck into this. It's a bit of a complicated. I'm not answering any more questions beyond the last question that was answered at 7:35. Um, right, the 17A. So the idea of this question is you have to, with many of these surds, when they're big numbers, you can simplify them to two numbers that times to give that number. And often there's a clue in the question, which is that root 5. So what I really would like to do is have something times root 5 that gives me 80, and that something is 16. 16 becomes 4 when you square root it, and then you just stick the root 5 onto it. So that's become that. With the root 180, again, I want to have something times 5, and that something is 36. 36 times 5 is 180. And that becomes 6 root 5. So we've got 4 root 5 plus 6 root 5, which now can simplify to 10 root 5. In this question, as I say, rationalize means that for some reason, don't ask me why, in maths, we don't like having these square roots on the bottom of a fraction. So there is a way to sort of make it look different by timesing the top and the bottom by that thing on the bottom. If you think about what this is, when you have a number divided by itself, it's just 1, isn't it? So actually what we're doing is timesing by 1. When you times by 1, the value of this doesn't change, but it's just going to look different. On the top, we're going to have 77 root 11, and on the bottom, we're going to have these two times together. When you times a surd by itself, you end up with the number inside it, essentially. And then the other thing you can do now is 77 divided by 11 is 7. So this has changed to 7 root 11. So we no longer have a fraction with the surd on the bottom. That was 17. 15, I'm just going to do quite a hard question, this. The square root of 80, from the previous question, we already know what this is. It was 4 root 5, wasn't it? Yep, so I've already done that. Same thing. With this one, right, there is a square root here. And we've got 2 and 2 over 9. This is a difficult question, this one. Really hard, actually. The 2 and 2 over 9, I'm going to change to a improper fraction. It is 20 over 9, which you may remember from Key Stage 2. So we've got the square root of 20 over 9 here. Now, this is the bit that you wouldn't get without me showing you. When you have a fraction with a surd on the, well, with square rooted, you can separately square root the top and separately square root the bottom. That bottom now has become 3. So I've got the square root of 20 over 3. Now the square root of 20 can be simplified to the square root of 4 times the square root of 5, which is 2 square root 5. So this has become 2 root 5 over 3. So all of this thing has become 2 root 5 over 3. Again, this is not great because I can't add these together at the moment because they've got different denominators. However, what I could do, and you may remember this from adding fractions, I could make this a 3 by timesing this by 3 and by timesing this by 3. On the bottom, I get 3. On the top, I get 12 root 5, which is being added to 2 root 5 over 3. Oh, 3. And now that we've got a common denominator here, the answer is 14 root 5 over 3, which now looks like that. That's a very hard question, but that's why I'm here. 19 in booklet 1. I don't know. Let's have a look. Is there a problem with it? I don't think there's a problem with it. I mean, I answered the first part of it. Yeah, I'm not sure what the problem is. So to make the answer as small as possible, here I'm going to put minus 8.9 because that takes away 8.9. That makes this as small as possible. But because we've got a minus there, if I put another minus here, there's no problem here. It's the fact that it looks the same, right? So that's probably why you're asking me this. But it isn't because that's a plus and that's a minus. So over here, the answer is minus 8.9. So we end up taking away the plus and the minus make a takeaway. Here, we need to put the plus here because otherwise because then we get a minus and a plus, which is a minus. We're trying to take away in these questions. Yeah, they're not the same. Questions A and B are not the same because that's a plus and that's a minus. Um, 15 and 17 done that. 13, booklet 3. Okay, there's a mistake in this question. That much I can tell you because I did it a little while ago. First of all, a negative power flips over your 8 and you are now still squaring it. A 1/8 squared is 1 over 64. There's a mistake in this question. I'll just tell you. It's supposed to be, not that you'd get it right, even if you had the mistake, but it actually should say 4 to the power x equals 8 to the power of 2/3. Um, Now, 8 to the power of 2/3 we can work out because we did it earlier actually. It's the cube root of 8 squared. It is actually 4. And once you have this, then you can see that x has got to be 1. Otherwise, that's the only way you get 4 to the power of something being 4. That's what it is. Um, and I think I did 13C already. Right, did that. 12B of booklet 2 was the last question I was answering. Expand and simplify. Yeah, there is an add in the middle of that, just to be clear. Squared means you multiply this bracket by itself. Um, the square root of 2 times the square root of 2 is the square root of 4, which will change in a minute. The square root of 2 times 3 is 3 square root 2. Then you'd move on to the 3. 3 times square root 2 is another 3 root 2, and 3 times 3 is 9. This becomes 2, right? Because the square root of 4 is 2. With any surds, if you get a number that you can square root, you have to do it. And then we've ended up with 2 add 9 here, which is 11. We've got 3 root 2 plus another 3 root 2, which is 6 root 2. And then I did 17b. Not doing that. It's not doing that. You meant question 16. Yeah, I think I've already answered that question in a different point here. 13, booklet 3. I think I've done that, haven't I? Yeah, done it. There was a mistake, as I said, in one part of it. Um, um, I don't know. When you say how do you know what that something is for 16, booklet 3, I thought I did this, didn't I? Yeah, I did a question very similar to this somewhere. I said that this can become the square root of 25 times the square root of 7, and then you should be able to figure out what the answer is from there. 16 booklet 3. Yeah, I've done that somewhere. 13 booklet 3. Did that. I'm not doing any more questions. No, not from there. I'm just reading what I've done because I've done making sure I've done everything. 16 in booklet 2 instead of 12B. Let me see what it is first. Yeah, no, I'm not doing that. I think I've done it in various points today already. 9 in booklet 3. Yeah, again, I've explained how to do to the power of 2/3, so I won't do it again. You do the cube root of that number, and then the answer, you square the answer. So cube root of 64 means you find a number that multiplies by itself and itself again to make 64. You should be able to figure out what that is. And then the answer that you get, you multiply it by itself, and that will get you there. Um, okay, that's it. Super. Everybody's questions are done. I will return in 15 minutes to quickly. Unfortunately, I can't do much else apart from a few questions at the beginning of the session for the next one as well for today. So there won't be much else other than dealing with some straight line graphs and simultaneous equations for year 10 and some functions and graph if anybody from year 11 rocks up. Right, I'll be back in a bit. Hello. Someone mentioned right at the end that I don't quite understand booklet two further indices. I've been through quite a lot of the questions from booklet two in this particular video. Um, as I say, it's not easy, so don't worry. Focus on writing up the notes if you have a problem with some of the questions. Does anybody from year 10 or year 11 have any questions on their homework? That's the thing I can. That's the only thing I can do today. I know one of you asked a question about fuel cells, but I'm not going to be able to get to that today. But yeah, is my camera working? I don't know. It is. Um, um, Question three on the year 10 book. I'll do that in just a moment. Um, the test for you guys in Newcastle, it's very complicated this time, is on the 24th, 25th, or 23rd, 24th, 25th if you're in Newcastle. Elsewhere, it will be the following week. Yeah, basically, that's what the situation is. Um, right, the question three on the year 10 booklet. Let's have a look. Question three says, work out the equation of a line through C that is parallel to AB. Okay, parallel. So first thing I do whenever I explain to people, yeah, we're doing booklet three. Whenever I explain to people, or whenever you're answering a question that says work out the equation of the line, just to clear your mind, write this down, which is what the equation of a line should look like, and you're going to try and fill in these two numbers. So you're going to try and find those two numbers. The m is the gradient of your line. Now you are told that your line is parallel to the line AB. The word parallel means that it has the same gradient as the line AB. So let's look at line AB and try and find its gradient, because if I can find its gradient, then the gradient of our line is the same as it. Now, because we have two coordinates here, 0, 1, and 2, 7, okay, that the line goes through. That's all the information you need to work out the gradient of a line. Because what you do is you work out the change in the y coordinates. So from 1 to 7, we add 6. And the change in the x coordinates from 0 to 2, we add 2. And it's the gradient is this number divided by this number. So the gradient of this line is 3, which means the gradient of our line is also 3 because they are parallel. So I have worked out the gradient of my line, or I've worked out the m. The only thing left to find now is the c, which is a little bit more complicated. Um, so the way you do this, the only way to do this, I think, is to figure out what this coordinate is. Because if we can figure out what this coordinate is, the y coordinate of it is the same as this. And then that is the y-intercept. You see what I mean? That is the y-intercept of our line. And so because we are told in the question that this is the midpoint of AB, I should be able to figure out what B is. I'll tell you how. If we go from here to here, right? How many across have I gone? Remember, this is 2 and this is 7. So I've gone, and this is 1. So I've gone across 2 and up 6. Okay, that's why I've gone across 2 and up 6 to go from here to here. Because M is the middle, we must do exactly the same again to get to B. We must go across 2 and up 6. If I go across 2 from here, I get to 4. If I go up 6 from here, I get to 13, which means that the y-intercept here is 13. And that is the answer. That's got to be the equation of the line. Uh, I don't know what question two, booklet three means. Is that the key stage three, booklet three? Then I'm not doing that at this point. Any other specific questions? Hmm. I'll just do this as well while I'm waiting for anything. Um, oh, question 7. Yeah, 10. Sure. Work out the equation of a line that's parallel to that and passes through that. Okay. Right. Again, when you see a question that says work out the equation of the line, I advise you to write down the following as your guide as to what you're going to follow. You need to fill in two numbers, this number and this number. Because they have told you that it is parallel to this line, parallel means it has the same gradient as that line. This line has a gradient of 5, which means our line has a gradient of 5. So we've done half the question just by taking that 5. The other part of the question is slightly more complicated this time because when it tells you that it passes through this point, what you have to do is plug in this x and this y coordinate into your equation. So y is -4, so I'm going to change the y to -4. X is -2. 5 times -2 is -10. And the plus c is there. This will allow me to work out what the c is because I will add this 10 to the other side. -4 add 10 is 6, which means that the answer to this question is y equals 5x, and then the c we just worked out as being 6. So y equals 5x plus 6 is the answer. I'll just move on to the other one. 3 and 9c in year 11. Let's do that. Not seen this for a while. Question 3. Oh, okay, right. Let me see if there's any other questions from that one. Let me just do the 4A in year 10 first, because it's just while I'm on it, I'll just do this, then I'll do that one. Um, Show that the gradient is -2. To find the gradient between 2 points, the easiest way to do it is to find the difference between the y coordinate. So how do you get from -5 to -9? You take away 4. And the difference between the x coordinates, how do you get from 2 to 4? You add 2. And then you do this number divided by this number. Okay, magic. Um, okay, so in question 3, the way we found out the c was by realizing that if you could figure out what this coordinate is, this y coordinate, then that is your c. Ignore this c. That was a bit confusing. It's the little c, as in it's this number here, because that represents the y-intercept of the line. So, for example, the reason... Oh, no, never mind. So if I could figure out what this coordinate is, then I would basically have my little c from the question. And the way I worked out what that was by realizing that it's in line with this point here. I figured out that the coordinate of B is, well, 413 by doing that little cross thing. So the coordinate here is 413. And that means the y coordinate here is 13. That means this is 13. And so that's why it's 13, because it is in line with that point, and therefore it is the y-intercept. For a just did that, and 8. Oh, really? Okay. Simultaneous equations. 2t and 1 coffee. I'm going to put 2t and 1c costs £3.40. 1t and 4 coffees costs £7.30. This is a simultaneous equation now. The easiest way to answer this is probably to make the t's the same by timesing all of this equation by 2. So if I times that by 2, that's 2t. Times that by 2, that's 8c. If I times that by 2, that's 1460. Okay, once you've made the t's the same, we can subtract. I'm going to subtract this way just because it keeps it positive. 8c take away 1c is 7c. 1460 take away £3.40 is £11.20. And c is £11.20 divided by 7, which I'll use a calculator for. Which means a cup of coffee is £1.60. Once I know a cup of coffee is £1.60, I can put it back and figure out what a tea is. And that is how we do that. Right. I shouldn't need to do this anymore, given what I just did a moment ago. So I will do this, but if there's any more questions that look like this, I'm not going to do them. Because if you are finding the equation of a line, this is I mean, this couldn't be much easier, really, because you know that this is what the answer looks like, and you should know that this number is the gradient. The question tells you that that is the gradient. So just put that number there first. And then to find the last part, we use this coordinate, right? This is an x and y coordinate that basically work in this equation. So you change the y to 19, you change the x to 3, so 6 times 3 is 18 plus c. You've worked out now that c must be 1 because 19 take away 18 is 1. And so your answer is just change that to 1 now because you just worked it out. And that is the answer. Okay. If it was not in line with 13, well, you would need another coordinate that the line goes through. In this case, that's the only way to find it. The other way to find it is what we just did, which is they tell you that your line passes through a point, and you substitute that point in, and you work out what the C is. In that particular question, because they didn't tell you that, there was a different way to do it. Question 10, year 10. Right. I think that's the last one I'll do from the year 10 booklet. The sum of two numbers is 15. Work out the two numbers. Right. Let's pretend that x and y are my two numbers. The sum of them is 15. So if you add them together, sum is 15. The difference between them, that means if you take one away from the other, it is 8. Right. What we can do now, because my x's are already the same, I can do a takeaway here. If I take away, just be careful when you take away. X take away x is nothing. Y take away minus y is actually y add y. So it's 2y. 15 take away 8 is 7. Y is therefore 7 divided by 2, which is 3.5. And then since they add up to give 15, you can figure out what x is. It's 11.5. Yeah, and the difference between these two is 8, and they add up to give 15. So they're your two numbers. Right, I'm going to move on to the only two questions I've been asked from the Year 11 booklet, and that will probably have to be it for today. 3 and 9c. Right, this is horrible. But work out f, g, x. Right, when you get a composite function, which is what this is, you put this function inside this function. So that means you take all of this and put it wherever there's an x in the other function. So if you did that, if you replaced this x with all of this, it would have x squared minus 2 on the top. And if you replaced this x with that, it'll have x squared minus 2, but also that plus 2. This minus 2 and plus 2 disappear. Okay, and this last part is the challenging part of this question, which is that when you have a fraction like this, or in fact, let me explain this in a different way that helps everybody. If you had this question, okay, 2/3 plus 1/3. That was a bad example. 2/5 plus 1/5. Okay. Then you know that because it's a common denominator, you could just put 5 there and put 2 plus 1 on the top. What you can do, right? There's 3/5 is the answer. In the same kind of way, sometimes with these fractions, you have to work backwards. So think of this as being exactly the same as this, except as a minus. Okay, I'll change that to a minus if you like. Okay, think of that as being exactly the same as that. What you could do with this is split it up. So you sort of work backwards from there back to there. So I could write this as x squared over x squared minus 2 over x squared. I could write it like that, right? Because that is the same as this, just as this is the same as this. It's like splitting it up. This now, something divided by itself is 1. And this is, okay, it's quite difficult. It requires, this actually, it's a weird sort of indices thing, but this is the same as 2x to the power minus 2. That's what it is, because it's 2 over x squared, and that minus basically flips it over. And so we have an answer that now looks like this. See? The plus and the minus don't matter. But that is the answer to that question. And then the other one was 15 I'll do. 9C. Same thing, isn't it? But we have to figure out what these are. So fx is 3 to the power 2x, and gx is x cubed. Okay, and then since gx is x cubed, fx 3 to the power 2x, and since we are putting this into there, that means we're putting this there. Okay, so if I replace this x with 3 to the power 2x, that's the x, and it's being cubed. Don't we then just multiply the powers together from your knowledge of indices? So 2x times 3 is 6x. I think that's the answer. Yeah, that's it. That is the answer. Because it's 3 to the power of something in its simplistic form. Okay, and then... Okay, I'll come back to question 10, year 10, and answer that question in a moment. 15, B and D. Ooh, yeah, that's a hard one. You wouldn't normally get asked. I don't know why this suddenly appeared, but I'll just tell you the answer to this question. Um, right, this graph, 10 minus x squared, looks a little bit like this. Okay, that's what it looks like. Okay, in fact, just on that note, actually, because this is relevant, that is the graph of y equals minus x squared. It's like an unhappy face. Okay, minus x squared plus 10, because that's what that is that moved up 10 units, which is what you should have covered in the lesson. Um, so that's what the graph is. When it says write down the range, it's unusual. I wouldn't expect you to normally get this question at GCSE, but the range just means what can the y values take? And what the answer to this question is, your y values in this graph are at most 10, and every other y coordinate is less than 10, isn't it? Because the graph is shaping downwards. And so when it says what is the range, you're supposed to say that the range is less than or equal to 10. That's what it means. Essentially, it means what can my y coordinates be? They cannot be anything bigger than 10. They could be exactly 10 if we're there, but every other y coordinate, because of the shape of the graph, is less than that. That's what the answer is. And then 15C, you said, right? Oh, D. Um, right. I'm sure there's a problem in this question. I feel like there was a problem in this question. Yeah, it just said that for some reason, and I don't think that that was meant to be there, which I think makes it confusing because it was repeated some accidentally over here. So we know that A is 4. So what is it? We've got 10 minus x squared for fx, and we've got gx, which is x plus 2a, and a is 4, so it's x plus 8, and x plus 3. Okay, so that is your two functions. As I say, I can see why this question will be confusing because that shouldn't have been there. Okay, because we already knew that from the previous part. Solve f of x equals g of x. So you take that, 10 minus x squared, which is that, put it equal to the other thing, which is x plus 8, x plus 3. You would expand all of these out to get x squared plus 11x plus 24. Okay, this is horrible. And then I'm going to move everything to the other side. So add the x squared to get 2x squared, and then take away the 10 to get 14. Oh, no. Um, Let me check if that works. Multiply to give 28 and add to give 11. Yeah, 7 and 4. Okay, right. So this can factorize to something. Um, probably that. 7x plus 4x is 11x. Yeah. That factorizes to two brackets. These are the two brackets, which means that x equals -2 or -7/2 if you rearrange that bracket. Um, and that was the answer to that question. If it's reflected in the y-axis, does that mean the x values will just be negative? Correct. Yes. It means that any x coordinate, its sign changes. So if it's a negative, it becomes a positive. If it's a positive, it becomes a negative. Yes. Um, yes, that's what reflection in the y-axis means. Yes, your x coordinates become negative. Um, right. Question 1010. So why would we not do so in 11b, all the x's we know. Let me have a look at that, sorry, first. Oh, it's such a difficult question, this one. Yeah, so in this question, reflected in the y-axis, your x's become negative. So it becomes, so that x becomes a minus x. That x becomes a minus x, minus 5. Sorry. Well, yeah. So that is still minus 3x squared, but then it becomes minus 4x minus 5. I believe that is the answer. Yeah. So you change each of the x's to become a minus x, and then you figure out what it is. That doesn't do anything to it because you square a minus x now. But the other bit changes to a minus. That's an awkward one, but it's good. Right. Let me answer this. Why would we not do the opposite, like y minus x? You can do. It shouldn't make a difference. Um, I see. So you're saying why would we do y minus x? Because if x plus y is 15, I don't understand why the same process would give us a difference between it. Well, it would work either way, I think. So if you're saying if we're saying x plus y equals 15, and then you're saying why don't we do y minus x? That should be fine. I don't see why that'd be a problem. But the problem with that is that it then messes up your the order of these things, which is not how we like to do simultaneous equations. So you might want to change if you want to do this, then you might want to change that to minus x plus y equals 8. Is that still y minus x, just to be clear? But it just means that your x are in line. Now what you could do is subtract this. 15 take away 8 is 7. X minus minus x is 2x. So 2x equals 7, and x equals 7 divided by 2, which is 3.5, which is what I got earlier, except I just got the other. We usually end up with them the other way around, but it doesn't make a difference because the point is we just need the two numbers. You're basically just calling x and y slightly different things. So in 11b, and all the x be negative. Question 13. Is that on the year 10 one? Um, that is the year 10 one, isn't it? Question 13. Right. This might be the last one I do. I think I've seen you on TikTok. Yeah. Question 13. Solve the simultaneous equations. Um, Big numbers, aren't they? There's several ways to do simultaneous equations. Now, it depends on what you're most comfortable with. I'm going to go with what I would do in this question. This might not be what everybody does, but this is what I would do. Okay. Which is I would keep the first equation the same, and I would multiply the second equation by 3. Because what that does is it makes that a 3y. Okay. So I've multiplied the second equation by 3. So 9x minus 3y, and then 19 times 3 is 57. What I'm now going to do might be unusual because I have made my y's the same, but one's a plus and one's a minus. When that is the situation, what you want to do is add your equations together. If the signs are the same, like both positive 3y, then you do a subtraction like you normally do. But when the signs are different on the numbers that are the same, you then do an add. Because what that does is it gets rid of this. 3y add minus 3y is 0. 2x add 9x is 11x. 53 add 57 is 110, which means x is 110 divided by 11, which is 10. So x ends up being 10. And then you'd go back and figure out what y is. If I just go back to this, 30 minus y equals 19, which means y is 11. So yeah, you not take away. So that's what I was just explaining. You would take away if you had made your x's the same. So if you were chosen in this question to times this first equation by 3 to make that a 6x and times this equation by 2 to make that a 6x, then you would take away because these are both positive numbers. Because I did it slightly differently, deliberately, was because I ended up with a plus 3 and a minus 3 here. When they're different, you take away to get rid of these. You see what I mean? So if you're getting rid of the x's by making them both 6x, 6x, which is the most common thing to do, you take away. I'm just giving you an alternative way, but the answer to that question is x equals 10 and y equals 11. If the lines are reflected in the x-axis, would it be the same? And if the lines reflected in the x-axis, you make the y coordinates negative. So if that coordinate there is, let's say, 5, -1, if it's reflected in the, where are we? X-axis, the x-axis is here, then it goes to there, roughly. Then this point now, which is the reflected point, is now at 5, 1, isn't it? So it's the y coordinate that has changed, as it were, in that situation. Number 2b. What would number 2b be? Oh, no, you're 11. So that makes the whole thing negative. So in terms of functions, which is the normal way that these questions are asked, this is slightly harder actually. Um, if you reflect in the x-axis, so if that's your original function, you in the x-axis, you put a minus in front of the entire function. So you're basically making the whole function negative. If it's a reflection in the y-axis, then you are only making the x part of it negative, like we did in that question that we just did. So this time, to reflect in the x-axis, everything has to become negative. So the way to do this is to go minus brackets x squared minus 1. So we're making the entire thing negative rather than just the x. That gives you minus x squared plus 1 because the minus minus makes a plus. Question 15, there's no common numbers. Don't believe you. Would you either know common? Oh, well, there is six, isn't it? Six. Just make them both a six. Let's do that. So if you times this equation. Remember, I think this might be the confusion. You can times one equation by a different number and the other equation by a different number. You don't need to times both of them. So I can times that equation by 3, to get 6x plus 12y equals 3. And I can times this equation by 2 to get 6x minus 10y equals 14. So in this case, I've made my x's the same. They're both positive numbers. So I'm going to do a takeaway now. 6x take away 6x disappear. 12 take away minus 10, be careful, is 22. And 3 take away 14, oh, this is horrible, is minus 11. And y is therefore minus 11 divided by 22, which is minus a half. So y is minus a half. You would then go back to an equation like this one. Sub in y equals minus a half there. 4 times minus a half is minus 2. 2x equals 1 add 2 is 3. X is 3 over 2. There is x and there is y. For those of you, actually, I'll just do one more thing. For those of you that might be fortunate enough to have a particular calculator. It really depends. Most people at GCSE won't have this, but in theory you could. Um, there is in some calculators a function to do simultaneous equations, which is good for checking your answer, as I'm demonstrating to you right now. You see this? Looks very familiar, given the questions that you've been doing. 2, 4, 1. That's 2x plus 4y equals 1. 3x minus 5y, 7. So you've got this whole setup, just like we have in the question. Press equals. It tells you that x is 3 over 2 there, and y is minus a half. That's what I got. So good way to check things, but don't worry. 4B year 10. Let me see what that is. I think I might have done that. Why do I feel like I've done that? No, I haven't. All right. So, okay. The only way to do question 4B is to work out the equation of this line. Right. In 4a, we know the gradient of the line is y equals minus 2x plus something. We don't know what the something is. I'm going to work out what that something is by substituting in one of these coordinates. It doesn't matter which one because it goes through a and b. So when y is minus 5, x is 2. So C is minus 5 add 4, which is minus 1, which means the equation of that line is y equals minus 2x minus 1. In order to check if this point lies on the curve, I'm going to sub in x is minus 301, lies on the line. And if I get 601 for y, then it does. If I don't, then it doesn't. So minus 2 times minus 301 is 602. 602 minus 1 is 601. That is what that is there, which means it does lie on the line. 602 take, yeah, it does. But that's how you do it. You'd have to find the equation of the line to know if a point is on it. So you sub in one and then you sub in the other. Sorry, no, you sub in one and you see if you get the other. Um, all right. We seem to have reached the end. As a reminder, let me just quickly get this up so that the people who are here get the benefit. Um, question 1. I might not do that. Yeah, I'm not going to do that. Because you should be able to draw a graph of y equals x plus 1. And then you can, wherever they cross is the answer to this question, because that's what simultaneous equations are doing. You are basically finding where two lines are crossing each other. To draw a line like this, you should do a little table of values like this. 0 to 5, you can just do, well, if you want to do all of them, you can do 0 to 5. But then you just follow what this says, y equals x plus 1. So you take your y coordinates and add 1. And then you plot these coordinates and you will have your line. And then wherever that line crosses this line is your answer. Um, yeah, this is recorded. It ends up on YouTube. It's quite long though, because I start from 7-ish. So you have to find the bit that you're looking for if you are after it. But it is recorded, yes. Yes, I was going to find something to benefit some people. Which I did send an email out about this, but just as a reminder, this is the last thing I will do, is give you some tips about something. Right. Earlier in the week, I there's questions coming. I sent an email. It's a bit small. This I appreciate, but I sent an email here with lists of topics with that you might get on the test that you will have in a couple of weeks. So basically, it's everything you've done up to now. So as of now, you have done straight line graphs and simultaneous equations in year 10 and function and graph transformations in year 11. So as of now, this is the cutoff. So whatever you do next week, basically, unless it will not should not be on the test. But remember that you also have a verbal test to do. And I think what I need to do in the next few days is redo the verbal tests that you will be getting. So because it's always the same every year, so I get sick of it. So I'm going to do them again. And what I'm going to do now is tell you the kind of things that I would normally ask based on these topics, the science topics, um, if I was doing a verbal test, right? And this therefore may possibly come up. So if I was doing the topic of the lungs and respiration, I would almost certainly ask you the equation for respiration. You should know that off the top of your head. I probably might ask you some of the adaptations of the alveoli in the lungs, like the fact that they have large surface area and thin walls and a good blood supply, that kind of stuff. Circulatory system, quite difficult to do a little quick verbal question on that, but I don't know. I might ask you for the names of the chambers of the heart, like the left atrium, right atrium, left ventricle, right ventricle. Digestion, you should know the names of the three enzymes, amylase, lipase, protease. You should know what they break down, starch, fat, and protein in that order. And you should know what they get broken down into, which is sugar, fatty acids, glycerol, and amino acids. You should know it that well. Um, Defense against disease. I do. I don't know. Ask you how a vaccination works. That's probably what I would most likely do. Tell me the whole process, what's involved. Injecting a dead version of a pathogen, white blood cells produce antibodies, antibodies destroy it, and if it reappears later, the antibodies can quickly be produced. Bonding, I think what we often do with bonding is ask you to, we give you a piece of paper and ask you to draw, for example, the bonding in carbon dioxide. It's quite a common question. And given you breathe it out, you should probably know what it looks like as a bond. Um, but maybe I might ask you just to make it a little bit unfair, is the differences between diamond and graphite. That's a nice one. Neutralization is quite easy, acids and alkalis, stuff like that. Quantitative chemistry, can't do too much of that verbally. Maybe ask you the equation to calculate moles, which is mass in grams over mR. Energy and physics, yeah, renewable, non-renewable stuff. Electricity, usually with this, I make sure you know the units for things like current being in amps, energy, joules, resistance, ohms, that sort of stuff. Waves, maybe I'd ask you what the difference is between a transverse and a longitudinal wave. I might even ask you how a microwave heats up food. That could be that. Right, that's that. Year 11, animal and plant hormones. Probably make sure you know the names of the four menstrual cycle hormones, FSH, LH, estrogen, and progesterone, and what they do. So FSH matures an egg, LH releases an egg, estrogen grows the uterus lining, progesterone maintains the uterus lining. That's it. Genetic A and B, hard again. Homozygous, heterozygous, the difference between those two words. What does that mean? Genetics B, we do things like evolution and selective breeding. Maybe ask you what selective breeding involves. That would be a good thing to ask you if you could just tell me what that involves. For example, in selective breeding, you take two of your best male and female things, cows, plants, whatever it might be, breed them together, then out of the offspring, select the best of the offspring. In other words, the ones that have the traits that you are looking for, breed them together and continue this over several generations. Redox and electrolysis, difficult again. Maybe I might ask you about the electrolysis of sodium chloride solution and what's involved, because that is the most commonly asked one, and you really need to know that. Analytical chemistry is really just make sure you know the tests for gases. How do you test for hydrogen, squeaky pop, test for oxygen, glowing splintery lights, test for carbon dioxide, lime water milky, test for chlorine, bleaches, damp, blue litmus paper. Same again for electricity in terms of units. Electromagnetism, possibly explain Fleming's left-hand rule, that thing. Yeah. Be able to explain what that means in terms of each part of it. I don't think of anything else. Right, I think that's enough. Yeah, assuming there's nothing else, I'm going to let you go for today, and I will be back next week. Can't remember what we're doing this week. Physics, forces for most people, I think. So we will